Hello and welcome, my friends in the YouTube world. Welcome to another notes PowerPoint on oceanography. And I'm excited to tell you that we are starting a new unit today all about journeying to the bottom of the ocean. And to do that, we need to look at the different land masses on the bottom of the ocean. And to understand that, we need to look at plate tectonics. So that is what we're going to be looking at today, all about plate tectonics. So you could see right there, we're dealing with plate tectonics. We are actually going to go today from slide 1 through slide 15. We're going to stop right before we hit plate boundaries, everybody. So I encourage you to pull up a chair, to take out that notebook, get those slides ready, get that pen and pencil ready to go, because we are going to embark on a journey that takes us way, way, way back to the development of the different types of continents and how they were formed. All right, so without further ado, plate tectonics, here we go. So we believe in this theory called Continental Drift. So in the 1600s, the first accurate world maps were produced, and you kind of see we do look at, there's Africa, there's North America, South America, Central America. We have Canada up there. We have the Indo-Asia continent, Europe, Japan. We have the north and southern boundaries as well. So we started to notice something back in the 1600s. If we looked, we could see that parts of South America looked like they fit right into essentially the armpit of Africa. Right, like a little puzzle piece. And maybe the part that sticks out in Africa kind of fits into where Central America is, right below North America. So all of these kind of looked like they started to fit together like puzzle pieces. And that led us to start thinking about continental drift and the theory that maybe our world was made up of these plates, these movable sections of Earth, okay? And the continents were on the plates. So as the plates moved below, the continents would move above. So as we would see at one point of time, the plate that was on, the plate that Africa sat on and the plate that South America sat on were together. And then all of a sudden they started to move apart. Now look at, they fit inside one another, right? But then they started to drift apart, and we could still see how they would fit, but they were hundreds and thousands of miles away. So we said, maybe these things are kind of moving around. Very, very slowly, but maybe they are moving around. So we got to thinking and we said, maybe 200 million years ago, all the continents were together. North America, South America, Africa, Antarctica, Australia, India, Eurasia, right? Europe and Asia together. And we said, well, maybe they were all one supercontinent. And we called that supercontinent Pangea. But how on earth do we make this claim without support? Well, we need to look at our data. We need to look at the facts. And the facts say that there are fossil records. There are fossil records of the same organism that are found on different continents, on the shores of different continents that look like they matched up, like puzzle pieces. And not only were there fossils of animals, but there were also fossils of plants. There were also deposits of coal and natural gas and petroleum. There were also mountain ranges that stretched from one continent and then picked up on the other continent, almost to prove the fact that at one time they were together. So you have all of this proof, all of this evidence that says, yes, all these continents were together at one time. There was this one supercontinent, Pangea, at one time. Okay, now think about this. Well, Mr. F, hey, maybe there were different animals on different continents. Well, okay, but how could an animal of a very warm climate how could fossils also be found in a very southern tip, in a very cold climate of a different continent? You're telling me that animal was able to survive over a broad range of variables, strains? Oh, maybe. What about plants? We know plants are so heavily dependent upon climate and rainfall and temperature. Okay. Well, maybe, Mr. F, maybe the animals crossed the land bridges and they brought seeds with them. True. But the amount of time that the glaciers were coming down and receding doesn't necessarily allow for enough time for all of these things to be dispersed as widely as they were. Okay, and seeds were way too heavy to be carried by wind and too fragile to cross the ocean. So we have all of this evidence pointing to Pangea, pointing to a time where all of these continents were together. We're not going to have to do a Pangea puzzle. Don't worry about that. So take a look here. This is looking at some of the plants and animals that were distributed among different continents. You could see in parts of Antarctica, you're finding the same plant as you do in South America, a very cold climate to a very warm climate. Same thing with Africa to Antarctica. Evidence of the Triassic land reptile Listosaurus. All right, so again, we're finding all of these fossils, all of these organisms, plants and animals across different continents to, in fact, provide evidence that all of these continents were mashed together at one time. So 200 million years ago, we had this Pangea. And then all of a sudden, Pangea broke into two larger continents. We had Laurasia, which was the northern hemisphere. It was composed of what we think to be North America, Europe, and Asia. And then we have Gondwanland, the southern hemisphere, which is South America, Africa, Australia, and Antarctica. And if you're coming here from another channel, if you're coming here from another school, and I totally botched that, feel free, you can make fun of me. Hey, I admit when I'm wrong, no biggie. So we've had these two continents that were broken up. All right, now, moving on, we can see here they are right here. We have the northern hemisphere and the southern hemisphere. It's kind of like what it looked like. Continuing on, we could see here the northern hemisphere being broken up and the southern hemisphere. Here's the namesakes right there, Gondwana and Laurasia. And we can see the separation over time. This is showing us Pangea breaking into the northern and southern hemisphere continents. And then they continue to spread apart until we start to see these defining Antarctica, South America, North America, Africa, Australia, Europe, and Asia. Okay, I will link these videos up at the end of our PowerPoint here. We've only got a couple slides left, guys. Hang with me. We're doing pretty good. So moving on, evidence. In 1908, Ernest Shackleton's expedition found coal in Antarctica. Coal only forms from vegetation that is buried by geological processes in warm, swampy locations, where it can allow for where it can accumulate faster than it could decompose. So my question is, if coal can only be formed in warm, swampy locations, how did it form in Antarctica? This would lead us to believe that once Antarctica wasn't always in a cold location. It was actually in a warmer location, which leads to the fact that these continents are constantly moving. And right now, we're just in a time where Antarctica is cold. But at one time, way back when, it was warm. It was in a warmer location. So I want to do four more slides. I just want to introduce you to some terms that could help with this plate tectonic before we move a little bit forward. Got to kind of switch gears here. So the lithosphere is the solid land. That's what we stand on. Okay, that's the ground. The asthenosphere is the semi-solid layer below it. It's like the putty, right? Like the jello or the pudding. The asthenosphere, is what the lithosphere rides on. So the lithosphere is our plates, our continents, and that's riding on this fluid layer, the asthenosphere, and that's how it moves. It rides on the asthenosphere, and we know this to be true now. And the plates float on the asthenosphere. They are the lithosphere, and there's more than a dozen plates. There are specifically two categories of plates. They are oceanic plates and continental plates. Oceanic plates are those plates underwater, and continental plates are the plates, the land plates, right? Oceanic plates are more dense and they are thinner than the less dense and thicker continental plates. We can see this is a breakup of the plates. We have the Pacific plate that takes up all this, the Nazca plate, the South American, the North American, the African, the Eurasian, the Indo-Australian plate, This is part of the Pacific plate. We can see this is a continental plate. This Antarctic plate is a oceanic plate. The Nazca plate is oceanic. The South American is a continental, so on and so on. And then this is also another diagram, and this is where I will leave you guys for today. This is another diagram showing the different plates here: the Pacific, the Nazca, the South American, North American, Eurasian, Indian, Australian, so on and so on. So the next time we meet, I will be showing you guys, or we'll be getting into plate boundaries and when they come together, when they slide past each other, when they move apart from one another. But in the meantime, I will ask you to please review this PowerPoint, watch the videos that will be located right there and right there, and have a wonderful day. All right, everybody, take care. See you guys. Bye.